This lecture is about constructs in concurrent programming, future and promise. Future is a building block of concurrency in concurrent programming. A future of type t denotes some value of type t, which is computed inside another separate thread. Because the computation proceeds in another thread, the result of type t may not be available right away. Usually, the value is available after the thread completes. On the other hand, creating a future itself takes no time. So for example, here we create a future of type string. Because creating future itself takes no time, we see that the statement after this statement can be executed right away. However, the statement inside the future can take a time, so it may take a while to see the effect of these two statements, which are executed another thread. This diagram shows the typical progress of future computation. Here, we create a new future called the build file. And after a while, the system creates a new thread for this future and starts executing the statement inside the future. While the future is in progress, calling this method is completed returns false because it has not completed yet. After the future completes, calling the method is completed returns true because the future has completed. And after the future completes, we can also retrieve the value computed by the future. So this is the typical progress of future computation. We can also create the future callbacks, which are executed in separate threads after particular futures complete. So here's an example. We create a future of type list string in this statement. So if we execute this statement in the main thread, at this point, we create a new future which is executed in separate thread. So this URL spec future is executed in separate thread. And this is how we create the future callback. We use this for each statement to create this callback. And this callback is executed after this URL spec future completes. So after URL spec future completes, we create another thread, and this thread executes this callback. And you can also use the result of this URL spec in the variable lines. So this lines variable is bound to the result of this future URL spec. This diagram shows the progress of the future callback. Here, we create a new future called URL spec. After a while, a new thread is created for executing the future. And here, the future completes. After a while, a new thread is created to execute the callback. And there happens to be correlation between this future and this callback. There are two possible outcomes of computing a future. The first is a future of type t completes normally, in which case we obtain a value of type t as the result. Or the future can fail with an exception or an error. In that case, we can use this failed method to create a callback for dealing with the exception or the error. This failed method creates a callback when the future fails with an exception, and moreover, this callback can take the exception as an argument so that we can analyze the type of the exception raised inside the future. This is an example of using the failed method of a future. First, we create a URL spec future of a type string. Then we use this failed method to install a callback for dealing with the exception from this future. So if this future fails with an exception, we execute this callback in a new thread, and this T is bound to the exception raised inside the future. Here are a couple of more comments on futures. First, fatal exceptions are not code. What this means is that if an ordinary exception is raised inside the future, such as an IO exception, you can catch this exception in the callback and then handle it. However, if a fatal exception is raised, such as out of memory error, then you cannot catch this exception in the callback because it is propagated directly to the execution context. Second, you can install callbacks either using for each or by calling this onComplete, onSuccess, and onFailure methods. And the guideline is you want to prefer this for each method to these methods because these methods may be deprecated in the future. Promise is another important construct in concurrent programming. We can think of promises as single assignment variables. For example, for promise of a type T, we can assign a value of a type T only once. When we assign a value of a type T, then this promise of a type T completes, and we can also start the future associated with the promise. In order to specify the future to be started when the promise completes, we use this future method. So this future starts when the promise completes. So here's an example. First, we create a promise of a type string, and we specify the future to be executed when this promise completes. So it takes the string, which is the value of the promise, and then executes this statement. And we sleep for 1 second, and we complete the future by assigning this value, this string, to this promise. And at this point, the future associated with this promise P starts executing, and therefore we execute this code block in a separate thread. There are several ways to complete the promise. For example, we can call this success method to assign a value of type T to the promise. Or we can fail the promise by calling this failure method with an exception of a type throwable. Or we can combine these two cases with another method complete, which takes an argument of type try T. There are also several variants of these methods. For example, we can call try success method with the value of type T. And this method succeeds only if the promise has not completed yet. Similarly, we can call try failure method, which succeeds only if the promise has not completed yet. Likewise, we can use this try complete method. It may not be obvious at first why promises are regarded as such a powerful construct in concurrent programming. So for example, why do we not just start another future when an action is taken on a promise? For example, here we take an action on a promise by assigning a value to the promise. Why do we not start another thread manually instead of relying on promise? The reason why promises are such a powerful construct is that they allow us to achieve separation of concerns or composability in concurrent programming. Specifically, we might have a concern about when an action should be taken. And we might have another concern, namely, what action should be taken when an action is triggered at all. And promises allow us to describe the first concern, when, and the second concern, what, independently of each other. So for example, we might have three different cases in which we'd like to take a particular action. And here, we just describe when a particular action should be taken. And here, we just describe what action should be taken, irrespective of when this action should be taken. In this way, promises allow us to separate the concern when and the concern what. And this is the beauty of promise programming and also the source of its power. We might wonder, what if we could combine the two concerns into a single construct? However, this turns out to be a very bad idea because it destroys the composability. Now we have to describe when an action should be taken and also what the action is in the same construct. And this complicates the concurrent programming significantly. As an example of using promise, let's consider a new operation OR on futures. Here's an example of using the operation OR. We create the future X, and we create another future Y, and we create yet another future Z by combining the two futures X and Y through this OR operation. The final value of this future Z is either the value of future X or the value of future Y, whichever comes first. In other words, whichever of X and Y completes first decides the final value of this future Z. And here is how we implemented this OR operation. When this OR operation is called, we first create a temporary promise P. And then we specify when this promise completes. Either the first future X completes or the second future Y completes. Finally, we just return the future associated with this temporary promise P. In this way, we can easily implement a new operation OR that combines two futures.